Hi, today we will be solving engineering mechanics 2 marks question from question number 31 to 40. So let's start. So this is question number 31. A wardrobe, mass 100 kg, height 4 meter, width 2 meter, depth 1 meter, symmetric about YY axis, stands on a rough level as shown in the figure. A force P is applied at the mid height on the wardrobe as to tip it about the point Q. Okay, at mid height, the force is being applied at mid height so that it can tip off. Tip off means topple. Okay, so about point Q so that the wardrobe topples. What is the minimum values of the force and the static coefficient of friction mu between the floor and the wardrobe respectively? Okay, so we have to consider the limiting condition. At limiting condition means when the wardrobe is about to tip off. So the contact will be only at point Q because the wardrobe is about to tip off. The contact will all be only at point Q. So we can comfortably say that the normal reaction will actually pass through the point Q because that is the only point of contact. Rest of the surface has almost left the ground, right? So the normal reaction will pass through point Q. Okay, so there will be friction, no doubt there will be friction. So friction will also be acting through point Q, and I can say at limiting condition the friction is the maximum static friction, right? What else? What other force is there? There is a weight, that is mg of the block, right? So now if you pay close attention, if you want to find out force Q, you just need to do one thing. It is about to tip off, but it has not tipped off yet because you're finding the answer at a limiting condition. Means till now it is in equilibrium. Right? It is a limiting equilibrium condition, but it is till now it is in equilibrium. So if it is in equilibrium, I can say summation of moment about point Q. Q को थोड़ा बड़ा बना देते हैं. Point Q equal to 0. So if you take moment about point Q, you can see the normal reaction will get cancelled out, the friction force will get cancelled out, there will be only two forces, and those are the force P, which is acting at the mid height. So I can write T into 2 meter, because the full height is 4 meter. Full height is 4 meter, half height will be 2 meter, right? This is a clockwise, and mg is producing an anti-clockwise, minus mg, and the weight is 2 meter, so the half of the 2 meter is 1, equal to 0. So this implies P is equal to mg by 2. What is m? 100. What is g? Is the value of g is 10 given? No. So I'll take it as 9.81 divided by 2. So what is the value of P? Force P is equal to, I can clearly see it is somewhere around 490.5. Right? There are two options, 490.5, 1981. So definite P is equal to 490.5. So this is one of your answer. Now I have to find out the friction force. Again, very easy, very easy. Right? So I can clearly say that this is the limiting condition. The block is impending motion. So I can say the friction force Fs max is equal to P at this condition. Both of them have just balancing each other, right? Because the block is not moving forward, but it is about to tip off. So at limiting condition, the force will be maximum static friction. So I can write mu into N is equal to P. So this implies mu into mg. N is nothing else but mg, you can clearly see, right? Is equal to P. So what it just implies, mu is equal to how much? P. P is 490.5. mg is how much? 981. So what is the value of mu? Mu is equal to 0.5. What is the value of mu? Mu is equal to, you can see it is 0.5. Okay, so it is pretty easy question. Let us move on to the next question. So answer is A. The answer is A. Let us move on to the next question. Question number 32. A ladder AB of length 5 meter and weight 600 Newton is resting against a wall. Assuming frictionless contact at the floor and the wall, the magnitude of the force P required to maintain equilibrium of the elements. Okay. So let us first try to draw the FBD. Now I am drawing the FBD on the diagram itself. I am not separately drawing the FBD so that it saves little bit of time. So let me say this is NA. Let me say this is NB. Friction है क्या? Little frictionless contact at the floor and the wall. So friction is not there, right? And then you have W, weight W, right? So any other force, the force P. So simple. These are all four forces, right? Actually, I should draw the letters separately and find out, but I'm not doing it right now. So you can see this distance is 4 meter. This distance is 3 meter. So we can say comfortably say that length of the rod will be how much? I don't think it will be required 5 meter, but still okay. Now we need to find out the force P. Let us write down the equation. Let us start with the equations. Summation of force in x direction should be equal to 0. This implies in x direction there are only two forces. Na is equal to P, or I can simply say P is equal to Na. Equation 1. Right? Summation of force in y direction equal to 0. This implies Nb is equal to W. Nb is equal to W. Equation 2. What else can I do? Can I take moment about point B? Summation of moment about point B is equal to 0. Right? So I can say W into 2. This is the anti-clockwise minus NA into 3 is equal to 0. Right? In place of Na, I can substitute P. In place of Na, I can substitute P. You can clearly see, I hope you can clearly see that the perpendicular distance from W to point B is 2. The perpendicular distance from Na to point B is 3. Right? So this is 2, you can clearly see, and this is 3, you can clearly see. Right? So from here I can say the value of Na is equal to W into 2 by 3, and Na in equation 1 we have already seen Na is equal to P, so I can say P is equal to W into 2 by 3. So W is 600 into 2 divided by 3. So the value of P is equal to 400. The value of P is equal to 400. Pretty simple question, right? Okay, let us move on to the next question. Okay, this is a very fantastic question from rotation. Let us try to understand. Very, very beautiful question. Similar kind of question has been asked one more time, right? And this concept that you are using, you might have to use a lot many times in the chapter of rotation. So let us see. A pin jointed uniform rigid rod of weight W and length L is supported horizontally by external force F. So this is a rigid rod of weight W. Definitely the weight must be acting through the sector. And it is supported horizontally by a force. There is support, right? Definitely there will be some reaction at the support, and there is a force. So these two things are supporting this rigid rod. Okay. Please pay attention to this question. This is a very fantastic question. Okay. Now, the force F is suddenly removed. At the instant of force removal, means we are asked when just at the instant when a force is removed, the magnitude of vertical reaction developed at the support is. So what is going to happen as soon as you start remove the force? The rigid rod will simply rotate about the hinge point. Let me say this is point O. Let me say the hinge point is O. So it will start to rotate about the hinge point. So we don't want to find, we are not asked what is the reaction after some time. We are just asked when you just remove the force. What is going to be the reaction at this point? Okay. So first, let us see to find out reaction. Okay, we can proceed. You can actually do this backwards. You can also do this backwards. To let us see. Okay, let me try to do it this backwards, uh, reverse engineering. Okay. So let us try to draw the FBD of this rod. So if I draw the FBD of this rod, if I draw the FBD of this rod, my dear, if I draw the FBD of this rod, let me draw the FBD of this rod. Let me say this is the rod. Okay. So what are the forces acting on the rod? What are the forces acting on the rod? Can I say just after the removal of the force F, there will be a weight W downwards and there will be a normal reaction in the upward direction. Any other force do you think? Do you think any other force? No, these are the only two forces. If this point is the center of mass, definitely the center of mass will be accelerating ACM. So yes, I can say there will be a inertia force. I can say acceleration of center of Mars will be downwards, right? There will be some uh, acceleration of the center of mass. Yes, there will be a inertia force MAC. The inertia force. I am assuming the inertia force is acting about the center. So at this instant, at the just instant of removal of force, this is the FPD, right? So if you want to find out the reaction, I can clearly see that normal reaction A is N is equal to W minus M into AC. Now, to find out the reaction, you can simply see that what you have to do is you have to find out the acceleration of center of mass. If you can find out the acceleration of center of mass, you will be actually able to find out the normal reaction because W is already given in equation. Answer is in terms of W. How to find out the acceleration of the center of mass? That is the equation. Now, we all know that acceleration of center of mass, since this is rotation, can I say the acceleration of center of mass, ACM, is equal to alpha into L by 2? Are bolo yes or no? Because the whole body is rotating about point 2. This is point 2. Point 2 comes out, this is point 2. And this distance, half of the length is L by 2. Half of the length is L by 2. So can I say acceleration of center of mass is L by 2? Just imagine the center of mass is having a circular motion about point 2. So A, tangential acceleration. Acceleration of center of mass is nothing else but tangential acceleration of the point midpoint is equal to alpha into L by 2. So now what I can say, I have to, if I can find out alpha somewhere, if I can find out the alpha, that is angular acceleration of the rod, I'll be able to find out the AC. Ultimately, I'll be able to find out normal. So how to find out alpha? Again, can I say, can I use this equation torque is equal to I alpha? Can I use this equation torque is equal to I alpha? Let me see. Can I find out what is the torque? So if I'm saying torque is equal to I alpha, let me see calculate the torque about point 2 and let me calculate the moment of inertia about point. So what is the torque about point 2? Can you tell me what is the torque about point 2? Can you tell me what is the torque about point 2? We will not consider inertia force while calculating torque because inertia force is an imaginary force. So these are the two forces acting. So can I say torque about point O can be written as W into L by 2? Yes or no? Can I say torque about point O is nothing else but W into L by 2? Right? This is equal to I. I about point O. So for the rod, ML square, I'm directly writing it ML Q. So ML square by 3 into alpha. Right? So what is alpha now? Alpha is equal to, what is alpha now? alpha is equal to W. I can write it as mg. I can write W as mg. Yes or no? I can write W as mg. So m and m will get cancelled out. M and m will get cancelled out. One L will get cancelled out. One set of L will get cancelled out. So alpha is equal to 3 by 2 G by L. Alpha is equal to 3 by 2 G by L. Right? So if you have alpha, this implies what is ACM? This implies ACM, A center of mass, is equal to, will multiply L by 2. So if I multiply L by 2, it will become 3 by 4 G. So this implies what is the value of N? From equation 1, I can get the value of N. N is equal to W minus ACM. Sorry, it is not ACM, M into ACM. I'm sorry. Not ACM, mass into force, M into ACM. I think that got removed. Yeah, I'm sorry for that. N is equal to W minus 3 by 4 G, or M into ACM. If I write it M into 3 by 4 G. So 3 by 4 mg. 3 by 4 mg is equal to W minus W by 4. So I can say N is equal to W by 4. So such a beautiful equation. Right, such a beautiful equation. So I have done it, shown it to you, through reverse engineering, how to actually come up with the solution. So this concept will be applied many a times in questions from rotation. So make sure that you have understood this concept, at least this point, right? How to use this, and this concept of torque. This concept of torque. Okay, let us move on to the next question. I hope this question is clear to all of you. Let us move on to the next question. Two steel truss members AC and BC, each having cross-sectional area of 100 meters square, are subjected to a horizontal force F as shown in the figure. Fantastic. All the joints are hinged. Very good. So this is a common data question. Question number 34. If F is equal to 1 kilonewton, the value of F is given. The magnitude of vertical reaction force developed at a point B in kilonewton is. So to solve this question, I use Lami's theorem. So Lami's theorem is again a very widely used theorem in the concept of truss. So make sure you're very comfortable with using Lami's theorem. Okay. So yes, I can, let me see the equilibrium of joints C. So there is a force F, which is given to be 1 kilonewton in part 1. Now there will be a force in this direction, that is FBC, and there is a force in this direction, that is F is, right? So I can calculate the angles. This angle is, you can see, it is 60 plus 45. 60 plus 45, that is equal to 105. This angle will be 180 minus 45. 180 minus 45 is 135. Yes. And the other angle will be, last angle will be 180 minus 60, because this is 180, right? This is 180 minus 60. This angle will be 120 degree. 120 degree. Right. So I can easily now calculate both. Let me first calculate what is FBC. Can I calculate FBC? FBC is equal to, I can say, okay, let me write Lami's theorem for you. So FBC divided by the sine of angle opposite to BC, that is sine of 135. Sine of 135 is equal to F AC divided by sine of 120 is equal to F divided by sine of 1. So I can calculate FBC. FBC is equal to, I'm directly writing it, F is, I'm putting it as 1, so it becomes sine 135 divided by sine 105. Sine 135 divided by sine 105, coming out with 0.732. 0.732. Right? So I need a vertical reaction at point B. So now this force, what will be this angle? Can I say this angle is nothing else but 30 degree? Right? So this FBC can be now resolved into two components. The horizontal component, cos of, let me say it is sine of 30, and this is FBC cos of 30. So FBC cos of 30 will produce the vertical reaction, right? So 0.732 into cos of 30 degree. Cos of 30 is 2. So I'm getting the answer as 0.634. 0.63. So option A, vertical reaction. So F reaction vertical at point B is equal to F BC cos of 30 is equal to 0.6. So definitely 34 is answer A. Right. Question number 35, if you see, this is a continuation. This is actually a question from strength from materials, but okay, कोई इतना बड़ी बात नहीं है. We can solve it here. Also, the maximum force in kilonewton that can be applied at C such that the axial stress in any of the truss member does not exceed 100 megapascal. Now, if you clearly see FBC is equal to 0.732 F. Let me write F here so that it becomes easy for you to understand. F, right? So in first question, F is given as 1 kilonewton. So I have, right? And what is FAC? Can you tell me what is FAC? Can you see that FAC is equal to sine 120 by 1 sine 105 sine 120 divided by sine 105. So this is equal to 0.896 F. 0.896 F. So you can clearly see FAC is greater than FBC. FAC is greater than FBC. So if that is the case, stress in the member AC will be more. So if I make the AC member safe, BC member will automatically become safe. So what I can say that stress in member AC is equal to FAC divided by cross sectional area of AC. So FAC is 0.896, right? Capital F divided by cross sectional area is given as 100 mm square, right? And the maximum axial stress can be equal to 100 megapascal. So maximum stress can be equal to 100 megapascal. So this is equal to 100 megapascal. So megapascal means Newton per mm square. So mm square will get cancelled out. So answer I will get it in Newton. Final answer I will get it in Newton. We want it in kilonewton. From here, this implies F is equal to I can write it as 100 into 100. This conversion from megapascal, that is Newton per mm, Newton, kilonewton, should be very, very clear to all of you. Divided by 0.896. So this is coming out to be 11,160 Newton. So divided by 1000. So this is coming out to be 11.16. 11.16. The force F is coming out to be 11.16. 11.16 kilo. 11.16 kilo. I hope it is clear to all of you. So let us move on to the next question. Okay, question number 36. Very, very simple question. One liner is need not actually worry at all. This is a very tricky question. So those who does not have the very good concept of friction, they will just be brought down by this question. Okay, let us see. A 1 kg block resting on a surface with a coefficient of friction mu is equal to 0.1. A force of 8 Newton, 0.8 Newton is applied to the block as shown in the figure. The frictional forces. Okay. So the concept here, you should know that a friction is a self-adjusting friction. It will act only that much which is required to prevent the relative motion, prevent the sliding, right? It will not apply in excess to that. So let us see what is the range of static friction. Range of static friction is always from 0 to mu into n. Range of static friction always varies from 0 to mu into n. So 0, so mu into n, mu is given as 0.1 and n you can clearly see how much is n here. N is in bracket if you write 1 into n is definitely mg. You can clearly see I'm not drawing it. Okay. So m is clearly mg into m is 1 and g is 9.81. So the frictional force it can vary from 0 to 0.981. So this is the range of friction. So if the force acting is 0, the frictional force will be 0. If the force acting is 0.5 Newton, frictional force will be only 0.5 Newton. It will not be acting mu s into n, right? And if the friction, if the external force, if the external force is 0.5 Newton, friction will be 0.5 Newton. If the external force is 0.8 Newton, what will be the frictional force? Frictional force will be acting is 0.8 Newton. The maximum value of external force can go up to 0.98 Newton. If the external force is 0.981 Newton, the frictional force acting will also be equal to 0.981 Newton. Right? That is a case of limiting friction. There is a case of impending motion. Frictional force is at the maximum value, so we call it Fs max, maximum static friction. Right? After that, if you increase the external force, right, the block will start to move. Okay? So the answer is 0.8. Very, very simple. Okay, let us move on to the next question. Question number 37. Consider a truss PQ are loaded at point P with a force F as shown in the figure. The tension in the member QR is. Okay. So this question, similar kind of question has been asked multiple number of times. So we have to use method of joints. There is no other way. So the procedure will be to find what, consider the equilibrium of point P, find out what is the force is member PQ, then consider the equilibrium of point Q and find out what is the force in member Q. So this is the only procedure possible. You need not find out the reaction, nor you can find out the reaction. You cannot find out the reaction because the dimensions of the sides are not given. Okay. So to find out, to consider the equilibrium of point P. So let us consider equilibrium of point P. Consider equilibrium of point P. So what are the forces? There will be three forces. You can see is the force F, PQ, and FPR. So this is the only combination of forces possible. All the forces will be radially inwards, right? This is the only combination possible. You try any other combination, you'll see that the net sum of the forces are not coming up to be 0. So this is the only combination possible. Now we can use Lami's theorem. We have used Lami's theorem multiple number of times. You see this is a very, very important theorem. So 45, 30. So how much will be this angle? 90 minus 45. 180. Sorry, 180 minus 45 minus 30. It is equal to 105. 105. So if this is 105, let me draw a line like this is 45. This is 45. 45 plus 90 is 135. This angle is 135. And this angle will be automatically 120. So 135, 105 is 240, 240 plus 120 is 360. Fantastic. So this angle is 105, this is 120, and this angle is 130. So you can use Lami's theorem and find out what is the force in member PQ. So let me see, let me say F PQ divided by sine of 120 is equal to FPQ sine of 120 is equal to F divided by sine of 105. Sine not 1 sine of 105. So this implies FPQ is equal to F. We'll directly calculate sine 120 divided by sine 135. So last, I think one of the question also had similar kind of values. Sine 120 divided by sine of 135. not 5, not 135, I have written 135. So it is coming out to 0.896. 0.896. ऐसे लिख देता हूँ 0.896. So this is equation number 1. Okay. Now let us consider equilibrium of joint Q. Equilibrium of point Q. So let us consider the equilibrium of point Q. So you can see, since the member PQ is under compression, it will push joint Q. So this concept should be very, very clear. Okay? The direction of forces you should be able to. The direction of forces you should be able to make out easily without much problem. So reaction will be in the upward direction, no doubt, and the force QR. So anyways, we are not asked with the nature of force. So okay, डायरेक्शन थोड़ा बहुत गलती हो भी जाए तो कोई दिक्कत नहीं है. F Q R. This F P Q. Okay, so this angle is 45. So you can clearly see that F Q R is equal to F P Q cos of 45. So 0.896 into cos of 45, that is equal to coming out to 0.63. 0.63 F. So answer is B. Answer is B. I hope it is clear. Okay. So similar kind of questions you will get multiple times. So try to understand this. Thoda sa you will have, there are 2 steps undoubtedly, but if you know it, it's a very, very simple question. If you are not making any calculation mistake, there are no chances that you are unable to solve this question. Okay, question number 39. 2 books of mass 1 kg each are kept on a table, one over the other. The coefficient of friction on every pair of surface is 0.3. Very good. The lower book is pulled with a horizontal force F. The minimum value of F for which the slip occurs between the 2 books is. Okay, fine. So minimum values of the maximum, all the equations of static friction will be, maximum 99.99% will be for limiting friction. Okay, will be for limiting friction. So let me draw the 2 books for you to understand. Let me say this is one of the books, and let me say this is the other book. So color light कर दें for you to understand easily. ठीक है. This is the other book. Okay. The lower book is pulled with a horizontal force P. The lower book is pulled with a horizontal force P. Okay. Kept on one table, one over the other. So there is also a table now. There is also a table. I'll have to draw the table. Okay. So lower book is pulled. Okay. With a horizontal force F. The minimum value of F for which the slip occurs between the 2 blocks. So for slip to occur, the friction should be at limiting value. For only after that, if you increase the force, there will be slip. Okay. So at limiting condition, there will be 2 friction force here. Let me say Fs1, Fs2. Right. So what is Fs1? Fs1 is equal to mu into N1. What is Fs2? Fs2. Basically, at limiting condition, I should write at Fs max. Better if I write Fs max. Okay. Okay. Let me say at limiting condition. So why am I saying limiting condition? Because I need to find out the minimum value of F. Right. So this is a case of limiting condition, and minimum value of F for which the slip occurs. Slip is about to occur. So at limiting condition, I can say Fs1 max is equal to mu into n1. N1 क्या होगा? If I draw the similar kind of question, I think we have done in last video. The concepts are getting repeated. You see, the concepts are getting repeated, isn't it? So mg n1, m1g let me say, right? And if you draw the next book, g m1g normal reaction. Now friction force will be there, definitely friction force will be there. I'm just drawing, trying to show you what is the normal reaction. Let me draw the friction force also. Okay. Yes, one question we have done it. So the friction force on the lower book will be in this direction, Fs1, Fs. Why? You have to see, you have to analyze the relative motion on the book. The friction force on the upper book will be towards right. So this is a very good concept. Try to think about this concept. How is the friction force this way? Let me tell you a hint. In which direction is the upper book, the black color book moving? It is moving towards right. Why is it moving towards right? It is because of the friction force. Initially, both the books will go together, na? Initially, both the books will move together. So why is the upper book moving along with the lower book? That is because of the frictional force. So in which direction is friction acting? Friction is acting towards right. Give it a thought, good thought. Tell me if you have understood it at comment section. Okay. At limiting condition, Fs1 max is equal to mu 1, and I can say Fs2 max mu into n2. Can you find out what is n1? N1 is equal to m1g. What is n2? N2 is equal to m1 plus m2g. Both mass are given as 1 kg. So what will be the frictional force? Now P is equal to Fs1 max plus Fs2 max. Let me substitute the value. Let me consider m is equal to m1 is equal to m2 is equal to 1. तो डायरेक्टली लिख देता कोई बात नहीं. m1g plus m2, सॉरी म्यू भी तो आएगा ये, म्यू into m1g, म्यू m1 plus m2 g. Substitute the value of m1 is equal to m2 is equal to 1, g is equal to 9.81, mu is equal to 0.3. 0.3 into 9.81 plus 0.3 into 2 into 9. It's coming out to be 8.829. So answer is P is equal to 8.829. So this is equal to 8.83. So is the 8.83. I hope it is clear to all of you. Let us move on to the last question for this video. That is question number 40 from conservation of angular momentum. Very fantastic question. Very fantastic question. Let us try. A 1 kg mass of clay moving with a velocity of 10 meter per second. So you can say this is the clay. This is the clay. This is moving with a velocity of 10 meter per second. Strikes a stationary wheel and sticks to it. Very fantastic. The solid wheel has a mass of 20 kg and a radius of 1 meter. Okay, the wheel has a mass of 20 kg and a radius of 1 meter. Assuming that a wheel and the ground both are rigid and the wheel is set to pure rolling, wow, the angular velocity of the wheel immediately after the impact is approximate. Now, so whenever you get similar kind of question, right, where the things are getting, where collision is happening, so immediately you should get the feeling that conservation of momentum should be the concept that needs to be applied here. So definitely some concept of conservation of momentum will definitely come because it's a collision. Now if you pay closer attention, you'll see the term angular velocity, term rolling, pure rolling motion is coming. So angular velocity rolling, what does it mean? Means Angular momentum. So basically what you have to do, you have to conserve the angular momentum. So what does the principle of conservation of angular momentum says is the net torque on the system of mass, net torque acting on a system of mass is 0, then the angular momentum of the system remains conserved. So what is the angular momentum? देखते हैं. Angular momentum. So I can say initial angular momentum. Angular momentum is represented by L. Conservation of angular momentum. Let me write it this way. Conservation of angular momentum. L initial is equal to L final. What is L initial? So about which point? So angular momentum is always found out about a point. So you have to fix the point. About which point we will try to find out the angular momentum about this point. Why? Because after the collision, when we find out the angular momentum of the wheel, right? So we'll find out the angular momentum of the wheel about the ICOR, that is instantaneous center of rotation. Let me see this point O, right? So definitely initial angular momentum and final angular momentum has to be calculated about the same point, right? So I'm considering about this point. So what is the angular momentum of the mass? Initially the wheel was stationary, so angular momentum is 0. Only the angular momentum of the mass. So angular momentum of the mass can be given by mvr. Mv is the linear momentum, r is the perpendicular distance from the point where angular momentum is being calculated to the velocity. This is r, mvr. Okay, so this is the initial angular momentum is equal to final angular momentum. So ball comes, the clay comes and sticks to the uh, wheel. Wheel is set into pure rolling. So if it is set to pure rolling, what is the angular momentum of the wheel? The angular momentum of the wheel is I omega. It is similar to mv. Momentum. Momentum is mv, mass into velocity. So angular momentum of the wheel is I omega. Mass is replaced by I, moment of inertia, mass moment of inertia, and linear velocity v is replaced by omega, that is angular velocity. So this is the final moment, right? So let me try to solve it. mvr is equal to I. So I is moment of inertia of the wheel. Solid wheel has mass of 20 kg and radius 1 meter, right? I So solid wheel, it is said to be a solid wheel. Okay, solid wheel means I'll consider it as a disc. Okay, I'll consider it as a disc. So if I consider it as a disc, so moment of inertia of a disc about 0.2, I can write it as 3 by 2. Let me see if I consider it as a disc, I get the answer or not. I should get the answer. 3 by 2 mr square IO, right? Moment of inertia of the disc wheel I'm considering as this because given a solid. अगर आंसर नहीं आता options है, then I'll consider it as a ring and again try it. ठीक है? Into omega. Can I write omega as v by r? Yes, I can write omega as v by r. Right? Velocity of the center of mass by r. नहीं. No, because this v is not same is equal to v, and I am required to find out the angular velocity only. So I'll keep it as omega. I'll keep it as omega. I'll keep it as omega. Okay. Let me substitute the values. Mass, initial mass is 1 kg. Velocity is 10. R is again 1 meter is equal to 3 by 2. Mass is again 20. R is 1 square. So what is the value of omega now? Omega, I can say it is equal to omega is equal to 1 by 3. Right? Definitely. This is the answer is. Now here I have done one approximation. I have considered the mass of the wheel to be 20. However, you know that the 1 kg clay is clearly written. It sticks to the wheel. After collision, it sticks to the wheel. So what kind of collision is this? This is perfectly inelastic collision. So what is the now total mass? It will be 21. right? But if I assume 21 and try to find out the answer, no, we will not get the answer. So what I have done, I have assumed it to be 20. I'm getting the answer, and you can see your answer is required to be approximately, and approximately I'm getting it as right. So there is no problem with this. I hope question number 31 to 40 are clear to all of you, right? So next video will be from 41 to 50. Okay, best wishes. Thank you. Take care.